We multiplied and divided rational expressions. What do you think we're getting into today? Not solving yet. We've multiplied and divided. Adding and subtracting. Yes, your quizzes are graded. I'll show you them during work time. We do multiplying and dividing first because when it comes to fractions, multiplying and dividing fractions is easier. Put the laptop away. Get out notes if we haven't already. So, 7.4. We're going to be spending a few days on this. Today we're getting into the basics of working with our rationals and adding and subtracting them. It's all going to fit under this idea of simplify. Now, a part of simplify is not only doing the operations, but it's also finding what? Excluded values. So we're going to be finding excluded values with this. Now, we're going to do our throwback problem first, as we have done many a times. And the fact that, much like multiplying and dividing, you have all the necessary skills to add and subtract. 5/12 plus 3/4. How do you add fractions? You need a common denominator. That is where adding and subtracting tends to have the additional challenge because of the fact that people tend to forget the common denominator, or sometimes they struggle a little bit with finding it. Once you get used to it, it's not too bad. Okay, 5/12 and 3/4. What would be our common denominator? 12, because I can make both of those denominators a 12. Essentially, you're looking for the least common multiple of the two denominators. So 12. Would you agree that this one is already 12? What do I do to this fraction? Times it by 3. Just on the bottom? And on the top. Why am I allowed to do this? It's not multiplying by 3. It's, or 3 over 3 is 1. You're multiplying by 1. Does multiplying by 1 change anything? No, that's why we're allowed to do this, because in all technicality, it changes the look of the fraction without changing the fraction. So I get 5/12 plus 9/12. Okay, we have the common denominator. Now what? Add what? Top, bottom, or both? Top. 5 plus 9. 14. Over the common denominator. Am I done? No, you got to simplify the fraction if possible. 14 and 12 both divide by 2. Giving me 7/6. Do I have to check for excluded values when it's just plain numbers? No, because there's no way those denominators are going to be 0. A 12 is not 0. A 4 is not 0. A 6 is not 0. No. 6x squared over 3y minus 12x over 3y. In order to subtract fractions, I need a common denominator. Done? So, following the idea of what I did on the first problem. Once you have your common denominator, you do the addition or the subtraction across the top. 6x squared subtracting 12x. Over the common denominator. Can I combine like terms up top? No, there are no like terms. Put the laptop away, please. So, I can't combine like terms. I would if I could. That is the next step. Combine like terms if possible. But there aren't any. So now I'm to the simplify step. How do I simplify when there's subtraction? We did it with multiplying and dividing. I start factoring. When I'm factoring, I start with greatest common factor. Greatest common factor of 6x squared minus 12x is 6x. Divide out of 6x and I'm left with an x and a minus 2 over. Can I factor 3y? If there's no addition or subtraction, it does not factor. Can I factor the numerator any further? No, because there's no exponents left in those parentheses, which means GCF was the best we could do. And then I simplify. Binomials with binomials. If there was an x minus 2 on top and an x minus 2 on bottom, they'd cancel out. That's not the case here. Monomials with monomials. 6x and 3y. Is there something I could divide out of both of them? Divide them both by a 3. That becomes a 2. That disappears. That's the most we got. 2x, x minus 2, all over y. Before I'm done, I have to check for excluded values. Now, excluded values can come out of anything that becomes a part of the denominator. Here's the nice thing with adding and subtracting. The stuff that can become part of the denominator is all going to be in the least common denominator. So even if my denominators were different, which they're not, the least common denominator equal to 0 will be enough to get all excluded values. Unlike multiplying and dividing, where you have multiple denominators going on, the LCD will be enough when it's adding and subtracting. That least common denominator. Okay, 3y equals 0. Solve. Y equals 0. Far too many people on the quiz said y equals 3 or negative 3. Please keep an eye on what operations happening between things. Between the 3 and the y is times. We divide. To divide by 0 or 0 by anything is 0. It's my only excluded value here. When it comes to this section, when it comes to chapter 7, the biggest thing that messes people up is not paying attention to what operation is happening. Yes, today we're focusing on adding and subtracting, but please do keep an eye on what operations between the rational expressions, because that is what messes people up. Because they try to add when it's multiply, or they try to multiply when it's subtract, etc. So keep an eye on that. This one is adding again. In order to add fractions, you need common denominator. Do I have that already on this one? Yes, it's another one with a common denominator. So I add. I've got 7x, and I am adding. Now, in all actuality, when you are adding multiple things, when you've got a binomial here, you have to make sure that you're adding the correct thing or subtracting the correct thing. Because if I was subtracting, I would need to distribute the negative. When I'm adding, do I have to distribute anything to the polynomial? No, it's just combining like terms. So I'm just going to write the 7x plus the 5x squared plus the 3x. I don't know what you're talking about. Clearly, there was never a 1 there. Now what? Combine like terms. Are there any like terms on top to combine? Yes, 7x and 3x. 10x. Can I also add the 5x squared? No. I'm going to go in standard form, so I'll start with the 5x squared, and then I'll add the 10x all over 5xy squared. Can I leave it like that? No. Now what? Factor out 5x. Start factoring that numerator because it's got a plus sign. I can factor out a 5x. Leaves me with an x plus 2 over 5xy squared. Denominator doesn't have a plus sign or a minus sign, so it's not going to factor. Can I factor further on top? No exponent? No. Can I simplify? Yes, binomials with binomials, x plus 2 only would simplify with an x plus 2 on the bottom, but the monomials, what divides out of both 5x and 5xy squared? A 5 and an x. Left with x plus 2 on top and y squared on bottom. Excluded values. Anything that ends up in the denominator is not allowed to be equal to 0. Anything. What are the things that are in the denominator? Where will I find them all together? The least common denominator that you didn't simplify. That will get you every single one. How do I solve 5xy squared equal to 0? One thing at a time. Split them up. Because these are all getting multiplied. It's already in a factored form. Is 5 ever equal to 0? No. X equals 0. X is alone. Y squared equals 0. Y is 0. The only way a variable to a power is equal to 0 is if that variable is 0. Subtracting this time. In order to subtract rationals, what do I need? Common denominator. I'm going to keep doing this because of the fact that it's one of the most common mistakes is mixing things up. Okay, so I need to figure out what my least common denominator is. To find the least common denominator, I am looking for the smallest things that all of them can multiply to become. In order to do that, if the denominators factor, I must factor them. Can I factor 4y? No. Can I factor 7y squared? No. When there's no addition or subtraction, it's kind of like working with regular fractions. Back on this first problem, when we had the 12 and the 4, you guys knew your multiples well enough to come up with 4 could multiply into 12. But essentially what you did here is you recognized that that 12 was 4 times 3. And between the two denominators, they had a 4 in common, and they had a 3 that was uncommon. And that the LCD has to have one of the things they have in common and everything they don't have in common. And that's what gets our common denominator. Now, you didn't probably do that in so many thoughts because it's plain numbers and you've moved beyond that. But that's essentially the process that we do. We look at what they have in common and what they don't have in common. I start by looking at the numbers. 4 and 7. Do they have any common factors other than 1? Do they have anything common that divides out of them, in other words? No. Which means my LCD needs both of them. Y and y squared, do they have anything common that would divide out of them? A y. So on this side, it's kind of like just I have a 4 and a y, and on this side, it's kind of like I have a 7 and a y and a y. And what the two have in common is the y. My LCD needs everything, one of the items they have in common, and everything they don't have in common. It needs a y from what they have in common, but it also needs the 4, the 7, and the other y they don't have in common. Four and 7 is 28. Y and y is y squared. Now, many of you probably could have come up with 28y squared without me breaking it down like that. And that is okay. I break it down like that because as we get more and more complex, some people need that broken down. That's how their brain works. If you're able to look at those and say, okay, it's 28y squared, good for you. Great. I'm glad you could do it. Not everyone can. Okay, that's what our common denominator is going to be. Now I need to make them the common denominator. What makes them the common denominator is the things that they were missing. This denominator had the 4 and one of the y's, which means it needs the other 7 and the y. Multiply on both top and bottom. I'm allowed to do that because if I do it by both the top and the bottom, I'm multiplying by 1. 7y squared, it's got the y, it's got the y, it's got the 7, it's missing the 4. And I do the multiplication. What is 7y times 3x? 21xy. Denominator, 28y squared. It should be the LCD. Minus, how do I multiply 2y plus 3 times 4? Distribute. You have to remember that your fractions technically have parentheses around them. Monomials didn't really need it, but binomials do. Distribute the 4. 8y plus 12 over 28y squared. Sweet, my denominators are the same. Now I can do the subtraction. When you are subtracting, if there is pluses or minuses in that second term, you must distribute the negative as you subtract. So I get 21xy from the first parentheses, and then it is minus 8y, and a negative times the positive is negative 12. Over 28y squared. Now what? If I want to simplify, I look at the fraction. I combine like terms if I can. Are there any like terms on top? No. And if there's pluses or minuses, in order to simplify, I must what? It starts with an F. Factor. I always start with what type of factoring? GCF, greatest common factor. Is there anything that divides out of 21, x, y, 8y, and 12? No. GCF is a bust. I try other forms of factoring, but is it in a form that I can factor? It's got 3 terms, makes me think AC method. Or it's quadratic-like maybe, so still AC method. But that requires the first term has a squared variable, the second term has a regular variable, and they're the same variable. Do I have that? No. If it's quadratic-like, then the first term has a variable to a power, and the second term has the same variable to half its power. Do I have that? No. Which means it's not AC method, because it's not quadratic, and it's not quadratic-like. And if it's not AC method, then shortcut will not work. Difference of squares will not work. Sum or difference of cubes? No, there's nothing cubic about it. Can I factor it? No. And if I cannot factor it, then when it's got pluses or minuses, I have to remind myself that technically it's in parentheses. And if that's in parentheses and the bottom doesn't have any addition or subtraction, will it simplify? No. Some rational expressions just don't simplify. And if you did your practice problems from last week, you came across a problem that was already as simplified as it could get. It happens. Excluded values. Easiest way when adding and subtracting is setting what equal to 0? Which denominator? Because yes, it has to be denominators. The least common denominator before you simplified anything. Now in this one we didn't simplify anything. Excluded values always come from denominators equal to 0. Specifically, if you do the LCD, you'll get what you need. 28 equals 0, y squared equals 0. 28 is never equal to 0. Y squared being 0 means y is not allowed to be equal to 0. Seven over x plus 3 minus x plus 10 over x plus 3. Subtracting. In order to subtract fractions, I still need common denominator. Do I have one? Yes. You'll notice that most of the problems I give you today do have common denominators. Today we're just trying to get the feet wet a little bit. Okay, so I subtract. Seven minus x. Say it a little louder, Isaac. Thought it was you who said it. Am I wrong? Is it plus or is it minus 10? It's minus. Why is it minus? It was a plus right here. Distribute the negative all over x plus 3. Before you factor, you must combine like terms. Any like terms? I got a negative x, and I got a negative 3 over x plus 3. Now I try to simplify. Top and bottom both have pluses and minuses, which means I need to factor both. Can I factor negative x minus 3? Yes. You technically should never leave a negative on the first term. I haven't really emphasized this because it wasn't as important in previous chapters, but in rationals it will be. You should not leave a negative on the first term. So I'm going to factor out a negative, aka a negative 1. If you want to write the 1, you can. If you don't have to. Divide by a negative, and I'm left with positive x and positive 3. Can I factor x plus 3? No, but it's got a plus sign, which means I should put it in parentheses to remind myself I tried. Can I simplify? Yes, what's on both top and bottom? X plus 3, they die a painful death, and I am left with negative what? 1. Everything disappears. Remember, when you're dividing, it becomes a 1, not a 0. Excluded values. Least common denominator was x plus 3. Set it equal to 0, and x is not allowed to be equal to negative 3. I'm going to give you one to try out on your own, and then we're going to do a slight change in instructions for the last little bit. And yes, I want you to try this one on your own. That means all of you. Give you a couple minutes to try it, and then we'll summarize it together, just in case anyone got stuck. means now we gotta type it after December. What do you notice about this one first? They have a common denominator, which means I can straight up subtract. While I subtract, I need to make sure to do what with it? Distribute that negative. X squared minus 4x minus 45 all over the common denominator. Combine like terms if possible. Are there any? Now, what do I need to do to simplify? Factoring in general. I'm hearing lots of forms of factoring being told to me. Okay, greatest common factor of the numerator is 1. Not helpful. It is quadratic, so I could do AC method. Can I do any of the shorter versions? Yeah, I could do just the regular shortcut. Two things that multiply to negative 45 but add to negative 4. Negative 9, positive 5. X minus 9, x plus 5. Okay, denominator. Greatest common factor is 1. That's not helpful. It is quadratic. I've got squared, I've got regular x. Full AC method, or can I do one of the shorter ones? I can do the shortcut because the leading coefficient is 1. So two things will multiply to negative 10 but add to 3. Positive 5, negative 2. It's fully factored. There's no exponents left in the parentheses. Can I cross anything off? Yeah. What's going to die a painful death? X plus 5s. They're gone. We've mourned them. We're left with x minus 9 and x minus 2. I had many people ask me at this point, okay, sweet, the parentheses disappeared. Can I cross off the x's? If you are ever in doubt of what you can do, create yourself a similar problem with just a regular fraction. Start with just a regular fraction and rewrite it in a way where it has this setup. So I did 8/10. Would you agree with me that I can write 12 minus 4 and 12 minus 2, and that is still 8/10? Now this has this setup. It has the same thing in front and minus numbers on both top and bottom. So I'm asking, can I cross off the x's? Well, let's imagine I crossed off the 12s. I would be left with negative 4 over negative 2, which is 2. Is 8/10 equivalent to 2? No. So the question, can I cross off the x's, is like, can I cross off the 12s? Was I allowed to cross off the 12s? No. Then am I allowed to cross off the x's? No. You can only cross things off on the top and bottom if they're fully factored and all pluses and minuses are in parentheses. Which means, in all technicality, this is still in parentheses, which means, can I touch them? No. That is its simplified form. Before I'm done, what's the other thing I need? Excluded values. Easiest way to do that is to set the common denominator equal to 0. How do I solve x squared plus 3x minus 10 equals 0? By factoring. X plus 5, x minus 2 equals 0, and split. X plus 5 is 0, gives me an excluded value of x is not allowed to be equal to a negative 5. X minus 2 equals 0 tells me x is not allowed to be equal to a positive 2. Where are we at for time? Okay. That's where I thought we were. Okay, you're going to see one other type of question today. And it's going to ask you to find the least common multiple of some expressions. The least common multiple of some expressions is essentially what we're doing when we're finding the least common denominator. We're finding the LCM of the denominators. But I'm not putting them in denominators when I ask for the least common multiple. I'm just giving you two polynomials. In this case, monomials. So, essentially imagine these are denominators and find the least common denominator. That's what we're doing. These are monomials. There's no addition or subtraction. When you're finding the least common denominator, you want to find the biggest thing or the smallest thing that they both multiply into. To do that, you want them factored. Can you factor if it doesn't have pluses or minuses? No. Can you factor if it doesn't have pluses or minuses? Still no. To do it when it is monomials in the denominator. To find the smallest common denominator. Start by looking at the biggest thing that divides out of them. What's the biggest thing that divides out of both 15xy and 18y squared? 3 for numbers. What about variables? 3y. Which means they are both 3y times something. 15xy is 3y times what? 5x. 18y squared is 3y times what? 6y. The thing they have in common is 3y. Everything they have in common, you need one of the thing they have in common in the LCD, or in the LCM in this case. So I need a 3y. I need to multiply it by all the things it doesn't have in common. The first term did not have in common a 5x. The second term did not have in common a 6y. Multiplying all those together will give you your least common multiple. Now, if you have anything factored, as in like parentheses, don't actually do the distribution. Just leave them in their parentheses. But if they're all monomials, multiply them together. What is 3 times 5 times 6? 90. What about the x's and y's? X and y squared. That is the LCM. When it's monomials, look for that GCF. Okay. few more examples of this, and then we're going to be done with this. When there's addition and subtraction, start by factoring. Can I factor 4x? No. Can I factor 2x plus 10? Yes. Can factor out of 2. Leaves me with an x plus 5. With the monomials, I'm looking at what's the biggest thing that divides out of both of them, and I'm breaking them down that way. What's the biggest thing that divides out of both 4x and 2? 2. I'm writing this as 2 times what? To get 4x. 2x. This is already 2 times the x plus 5. What do they have in common? Just the 2. My least common multiple needs what they have in common and everything they don't. They have the 2 in common. Not in common is a 2x. Not in common is an x plus 5. Simplify by multiplying the monomials together. 2 and 2x is 4x, and leave the binomials as the binomials, x plus 5. That is the least common multiple. That is what you would need for a denominator if those were the denominators in your fractions. X squared minus 9 and x minus 3. I notice addition and subtraction, which means I must factor for both of them, if they factor. Can we factor x squared minus 9? Yes, greatest common factor is 1. It is quadratic, which means I would think about AC method, but is there a shorter method to x squared minus 9? What can I do for x squared minus 9? Difference of squares. Or could I do the shortcut? Yeah, either way. It's going to turn into 2 binomials. Both are going to start with what? X. What do they come both end with? 3. And in difference of squares, what's the sign? One's a plus, one's a minus. Okay, that's the first one. What about that x minus 3? Can I factor it? No. If you cannot factor and it's got a plus or a minus, what do you do with it? Leave it, but put it in parentheses. What do the two things have in common? X minus 3. Now, when you're talking about binomials, it has to be the entire binomial in common. Which means my least common multiple needs to have an x minus 3, because that's what they have in common, and it needs everything they don't have in common. What do they not have in common? First one's got an x plus 3. The second one doesn't have anything that's not in common. That's my LCM. That gives me everything. Final problem. Try it out on your own. Once you think you've got it, after I finish it on my own, call me over. Oh, and just a little reminder, in the least common multiples, the binomials just stay the binomials. It's only the monomials that actually get multiplied together.